We're going to walk through an example where we are going to find the accumulated area under a function. We're going to let g of x equal the integral from a to x of f of t dt, where f is the function whose graph is shown. Down here we can see what f of t looks like. We are going to find the accumulated area by evaluating g of x for the values x is equal to 1, 3, and 6. This example illustrates how g of x represents the accumulated area under our function f of t from 0 to any point x. I'm going to go ahead and recopy what g of x is. Let's put it right over here. G of x is the integral from a to x of f of t dt. If we look up at our graph of f of t, we can see that t starts at 0, so that tells us that a is equal to 0, and we're going to find g of 1, g of 3, and g of 6. Let's start by finding g at 1. All we have to do is we have to replace x with 1. So this is the integral from 0 to 1 of f of t dt. If we look up at our graph, the integral from 0 to 1 of f of t dt is this area right here. It is a triangle, so we can write our answer as 1/2 the base times the height. Let's see what that is. This is 1/2, our base is 1, and our height is 1, so we get the value 1/2. So g of 1 is equal to 1/2. Now let's find g at 3. This is the integral from 0 to 3 of f of t dt. Because we already know what the integral from 0 to 1 is equal to, we're going to split this integral up into the integral from 0 to 1 of f of t dt plus the integral from 1 to 3 of f of t dt. That way we don't have to do double the work. This integral we already found to be equal to 1/2, and then this integral is this area right here up on our graph, and because it lies below the x-axis, it is going to be equal to minus 1/2 its base times its height. Let's see what that is. G of 3 is then 1/2 minus 1/2. Pull this graph back down. Our base is 2 and our height is 1. So this is minus 1/2 times 2 times 1. And this gives us 1/2 minus 1, which is equal to minus 1/2. Let's go back up here at our graph because I want to show you something. Notice that in our graph, as we go from x is 0 to x is 3, there is more area under the x-axis than there is above the x-axis, which is why our answer is negative. Now let's find g at 6. This is the integral from 0 to 6 of f of t dt. Because we know the integral now from 0 to 3, we're going to split this integral up, and we're going to integrate from 0 to 3, f of t dt. And then we're going to add on the integral from 3 to 6 of f of t dt. The integral from 0 to 3 is equal to minus 1/2. Now we need to find this integral. Let's go back up and look at our graph. That integral is the area under this triangle right here. And this triangle has a base of 3 and a height of 3. So this part is going to be 1/2 base times height, and this is 1/2 3 times 3. Let's see what this gives us. We have minus 1/2 from our first integral, and then we have 1/2 times 3, which is 9. So this is 9 minus 1 over 2, which is 8 over 2, and this gives us a value of 4. This tells us that the accumulated area from 0 to 6 is equal to 4. It makes sense that our answer is positive because if you look at the red triangles, you can see that there is more area above the x-axis than there is below the x-axis.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.